I am going to do something out of character, and I'm going to make you guys very happy in a second. But we finished this side of this paper, I'm pretty
Yes.
sure. Yes, we did. So one big thing that came out of limit questions is the more you know the shape of these functions, the easier these questions, many of these questions will be. Yes? If you know the shape of natural log, the limit is x goes to something of the natural will be easier because I know where the asymptote is. That relates to the infinity. It could be the limit answer. Are you guys semi with me? On this side, has anyone dared to look at the other side?
No.
I understand. All right. Okay, let me see if I can say something.
Epsilons and deltas are the really stupid people.
Okay, I'm not sure what to do with that.
They will,
I am going to make section 2-4 extra credit. Let me just put that out. Yes. So if you don't do section 2-4 homework, you're fine. If you do it and you get enough of them right, it'll actually increase your homework grade a little bit. So you have a chance of having a higher than 100 homework grade. Higher than 100 homework grade. Very quickly. If something is the limit of a function, at some point, I have to be able to determine, I have to get close to it, correct? Does that make sense? If something really is the limit, there's no way it can never get close to that number. It's got to eventually get close. Does that make sense? The thing that's killing me right now, I hate that I have to skip, but if I'm going to let go of something to get us back on track, because we are a little behind where I want to be, it's got to be this section, which really sucks. But this is how I define close. Given, so this is called epsilon. This little dude, epsilon. Given a distance away from the limit, so somebody tells me how close they want me to be to the supposed limit, I have to be able to find a little area here around my input so that I am within this close to the limit. If I cannot do that for some number, then that's not the limit. So all this is really saying is, if that really is the limit, at some point I have to be getting arbitrarily close to it. You guys all with me? And I use the word close a lot with limits, and one thing I love about this section is it's kind of formalizing the idea of close. So this is what we call a neighborhood, believe it or not. This is a mathematical term. This is a neighborhood of my input, and this is a neighborhood of the supposed limit. Right, little neighborhood. Oh, okay. How you guys all doing? You're all like, I'm zoning out because you said I don't know what to do this time. But if you want to try it, the work is actually pretty straightforward. It's, and again, it kills me, but I have to because there's just no time. It's one of our first little proofs. And it's really kind of nifty. Okay, so I'll let it go. So there's an example worked out of the work here. I can do this if somebody wants me to and show you later. If anybody wants to do that, I can kind of show you this as an example. But for today, I'm making section 2-4 extra credit. You've got this as sort of a template if you want to give it a try. If you don't have time, I understand.
4x minus 3 is 6 over x minus 3 becoming 4x plus 12 minus 24.
Where are we looking? Sorry.
The little side work
Oh,
thing, yeah.
yeah, because I can factor the top.
Oh.
Right here.
Oh,
See that?
yeah.
Yeah. Yes.
How do we determine where the zone?
Where the what?
Oh,
Sorry?
I was looking at how do you determine what the red zone range is?
Oh, this is what's given to me. Given epsilon, so I know how close I need to be. I need to find out how close I have to be to the input to make it that close to the limit. Okay. All right. I'm going to let that go. Really hurts me. Just so you know, a lot of my colleagues don't even cover section 2-4, so you're all like, just be like that, Jeff. And I am sort of.
Yeah, I don't think we covered this last semester.
Yeah, I had to let go of it last semester too. So. It's just the way it's going. Okay. Last time we did continuity, which was this side, because I skipped 2-4, because at that time I was like, I might be making extra credit, I wasn't sure. So So we did this last time, this is section 2.5.
Mhm.
Can anyone tell me very quickly, continuity, what does it take to be continuous at some point? What must be, two things must be true.
It has to. Good.
So that means the limit must exist, which means, you know, if you break it down, it's gotta be approaching the same thing from both sides. So it looks like it's approaching the same thing, and
And then the function
it
value
actually
has
gets
to
there.
be-
The function is defined to be that. So the limit as x goes to a of f of x must equal f of a. That one statement captures everything. The limit exists, and it's equal to the function there. So it's not an open circle, it's closed. Are you guys with me? So they fill the pothole, and this time they hit it, and so you can drive on that road. Okay, maybe. That's continuity. That's what continuity is. Okay. So what we're gonna look at now, for a moment, section 2.6. See if this sounds familiar to anybody. Does anyone remember how to find? Let's say I give you this function here. Do you remember how to find? I don't know the horizontal asymptote of this.
The horizontal asymptote, that's the ratio of the
It's gonna be
two.
like 0.5 or something?
So let me make sure. Let me slow down.
So it's
What is a
half.
horizontal asymptote? Careful, that's vertical. So horizontal is this way, I like it, but what's it mean?
The value of y the graph will never reach.
Value of y that the graph, not just will never reach, this is a bunch of values that the graph might never reach, but it has to be getting closer, so what does that sound like we've talked about? Limits.
Limits.
So somehow this is related to limits,
So-
depending on your pre-calc teacher, they might use a limit notation or not. Back in pre-calculus, when we had rational functions, we had three main options for horizontal asymptote. Either the degrees could be the same, like they are here. Do you guys agree their degrees are the same?
Yeah.
Does the top or the bottom grow much faster than either? No, they're both kind of lockstep. So I'm not gonna go through the whole derivation, because you should have done it in pre-calculus. The horizontal asymptote here will be the ratio of the coefficients of the highest degree terms. What the shit does that mean, Jeff? If I plug in a really big value for x, the output will be about 0.5. The bigger my inputs get, the closer it's gonna get to 0.5. Okay. So a way to write this then is the limit as x goes to infinity of this function is 1/2. Yes?
The ratio of
The leading coefficients, the ratio of the coefficients of the highest degree terms, which is also called the leading coefficients. So if you got a question like this, can anyone see what the answer is?
So the bottom's got a higher, no, it's not, it's the same.
Don't assume. Don't assume anything. What's the degree of the top?
One.
No.
No, it's 3.
3. Not the first guy,
It's
it's the
1/7.
highest guy.
Yeah, exactly.
So it's 1/7.
Damn you, Jeff, you're tricky. So what does this come out to be?
Negative 1/7.
Careful, it's the ratio of the coefficients of the highest degree terms, so yeah,
1/7.
I'm with you, negative 1/7. Some people said 4, so. So I just put the top out of order, so, you know, be careful. You guys with me? Is that coming back? Do you guys remember that? So what about this situation? Yeah, because now what's growing much faster? The bottom. So I got the top growing, but the bottom is growing way faster. So I got like 1/2, 2/20, 3/200. I mean, that's getting small, small, small. So that's going to go to freaking 0. Does it ever get to 0? No, and that's the whole idea of an asymptote, right? Now you gotta be careful with horizontal asymptotes. Do you guys understand you can actually cross through them
Mm-hmm.
an infinite number of times? So for example, so this is 0. I can have an asymptote, yeehaw, and I can have this going on. All that needs to happen for it to be a horizontal asymptote is over time, my function gets close in, arbitrarily close to it. So a horizontal wall is not as strict as a vertical wall is, you cannot exist here. The horizontal wall is, hey, come here eventually. Right? You guys come Okay, okay. So really, you're building off of pre-calculus knowledge to make limit questions easier. If you have a limit question about a rational function, thank you. Now it's just pre-calculus, right? And of course, the one I have left out is infinity.
Just where it's asking.
So what's the answer?
Y equals X.
Does not exist.
There is no.
Oblique asymptote.
So I'm not pre-calculus, so I'm not asking for the asymptote, I'm asking for the limit. Does not exist is not good enough.
It's a slim.
It goes to
I don't care about the asymptote, I want to know the
It goes
answer to
to-
the limit.
positive infinity.
Positive infinity. I love it. Because when x is really big, how much does 4 matter? How much does 2 matter? Not. Isn't that just x? And so it's going to go to positive infinity, right? You guys kind of with me?
Yes, stupid thing.
Yes.
So if there was a negative x, it'd go to negative?
Oh, you're right. Let me make one sort of not like you said, just because I'm a math teacher. What do you think that is?
Negative.
Yeah, because isn't this always positive? X squared? But then what's this? Isn't this always what as I go to negative? This is always going to be. This is always going to be negative. So this is going to be negative infinity. Okay. So what matters is if I'm growing unbounded, or this, growing big negative, growing big positive, am I always positive or am I always negative? Then I tell which one of those it is. Okay. Whatever you say, John. Okay. So power degree's the same, ratio of the coefficients of the highest degree terms. Lowest, the denominator higher, 0. Numerator higher, some kind of infinity. I like it. So what about this thing? We've seen something like this before. Let me make sure I do all the various stuff. Yeah, we can do that. What do you guys think about that one? Yeah, you know it's some kind of infinity, correct? Because the bottom is going to
0.
So the two main types of limits investigated in section 2.6 are the limits as x goes to infinity or negative infinity, or a limit whose answer is some kind of infinity, right? As the bottom approaches 0, all the numbers, are they positive or negative? Because what am I subtracting from 5? What kind of number? A number that is bigger than 5. So they're always negative, so the answer is negative infinity.
Because of the negative sign there?
That's one reason, but because I'm approaching from above 5, let me not say above, from the right of 5. So I'm doing like 5 minus 5.1, 5 minus 5.01. It is eternally negative, correct? 5 minus number bigger than 5 is negative, yes?
Confused with the positive or negative.
Again, I know this is going to some kind of infinity because the bottom's 0.
Right.
But it's not good enough to say infinity, you have to determine which infinity. I'm eternally putting numbers that are bigger than 5 in for x, correct? Okay. 5 minus a number bigger than 5 is negative, yes?
Oh.
Always. So it's
Okay.
going to, I knew it was going to infinity, now I know they're always negative numbers, negative infinity.
Now that makes sense.
Okay.
Why are you always substituting in numbers that are bigger than 5?
Yeah, what the hell's wrong with me?
Because of the plus.
What is it telling me to put
Means
it?
it's
What is
going
it telling me to
right.
put it? Okay, okay. So it wasn't my choice. I had to do it. I was like, I didn't want that to happen. I don't like negative infinity. It's weird. Yeah.
You want us to to show where? You want us to explain words?
That would be great, but know how to figure it out. Yeah. Just understand that there will be times when I won't let you use a calculator, for example. You can just graph that and go, well, I see it. No, but that's not good enough. Yeah. Okay.
Like for the homework.
It's up to you how much you do the homework without a calculator. Okay. So what about, let me come back to this idea. This is something you did not see in pre-calculus. What in the shit do I do with this god-awful thing? I like the idea, but no, definitely not. But I love the idea, because you see a radical, and that's what I've been saying. But real quick, do you see how the radical is only one term? Conjugate, we normally think of it like rad x minus 7, and then you multiply rad x plus 7. Okay. But I like the idea, it's a radical, so you think conjugate, but no.
Get rid of the extra stuff, just look at the bigger like ratios. Maybe just look at the root 4x to the 4
Sort of.
over to
Sort of.
Multiply by a square.
No.
Square the top.
So real quick, what's the degree of the bottom?
2,
What's the degree of the top?
4.
Nope.
1/2.
Nope.
No?
I like that though.
2.
2! Yeah, the top is degree 2. Do you see that?
Because it's the
If I square root and next to the fourth stuff, I get x squared stuff, don't I?
Yeah.
Are they the same degree? What's the rule? The rule doesn't care.
It would
If
be
one of them is
1.
in square root.
So it's
Same degree.
It would be 1.
Ratio of the coefficients. What's the coefficient of the x squared on top?
2.
2! Good. Square root of 4 is 2. And what's the coefficient on the bottom? So what's this limit?
1.
Kick ass. This is the exact same problem as the one we did earlier here. The idea behind this problem is the same as the idea behind this problem. Yes?
I don't get why you're allowed to like take that 4 from under the square root and like just.
I didn't. No, I didn't.
So-
Doesn't it say the square root of 4?
Well, yeah,
So I did the square root of 4. I didn't take it out.
Like even if it's like all 5.
All right, you ready? Okay. Here is the full technical approach. I like how some of you guys are gonna be like, why didn't you show this from the beginning? Well, you tell me, watch this. Everybody agrees now that they're both second degree? I'm gonna divide top and bottom by the highest degree I see. If I divide the top by x squared, will I be able to get it inside of the radical? Because what's the only way I can divide two things if one has a radical? The other one has to have the exact same kind of radical. You with me? What's square root of 6 divided by 2? You don't know. What's square root of 6 divided by square root of 2?
3.
Square root of 3. Half of 6 divided by half of 2 is half of 3. So it must be the same root to be able to do shit between them, yes? Okay. So I'm not going to divide by x squared, I'm going to divide by something that's equal to x squared. I'm going to divide by the square root of x to the 4th. Did I divide top and bottom by the same thing? Yes, okay. So doesn't this become 4 minus 3 over x cubed plus 1 over x to the 4th, yes? Over 2 plus 5 over x squared. And we talk about each one of these, what are they going to do when x gets really big? What is each one of those going to do? Go to 0. Square root of 4 is
2.
divided by 2 is 1. Okay. So don't do all this shit. This is unnecessary. But this is necessary, but hopefully your pre-calc teacher showed you something like this for the ones we did earlier. It's exactly the same idea with the radicals. How you guys feeling? Now, real quick, if this would have been plus 2, then I would have thought conjugate, right? Okay. And that would have been horrendous. So thankfully it wasn't that. What about this? What's up?
Go back to that last question.
Maybe. Okay, what's up?
So on the very bottom, like you cancel out the 0, 0, and then the 5 over x squared.
I'm sorry, yeah, they're all 0. I just put the line because it was the same idea. They all go to 0 because it's constant divided by big ass number.
And then you have 4, square root of 4 over x.
Yep. Square root of 4 is 2 divided by 2 is 1.
So that verifies what we got earlier. Okay. So the shortcut now is they're both second degree. Look at the coefficients of the highest degree terms, take the ratio. And you see why, because the same thing would happen every time. All right, what about that? And this would be sitting in a section of a quiz or a test where you could not use a calculator. So again, what's the thing that saves you with limits? What did I say earlier?
Shape.
Shape of functions. What's a tangent look like? Yeah.
It looks like
Looks
a
like a
cube.
cubish, but like stuck in the walls, right? Where are the walls
Go.
for a tangent?
0 and pi.
That's for cotangent. Negative pi over 2 to pi over 2. You guys with me? Inverse. Visually, what does it do? Flips it. So now my function's gonna, so it used to, the domain used to go from negative pi over 2 to pi over 2. Now what's gonna go from negative pi over 2 to pi over 2? Range. So as I go to infinity, pi over 2. So an inverse tangent looks like this. It's just a tangent that's been flipped because that's what freaking inverses do, yes? So now I know if I let x get really big, the outputs are getting closer to pi over 2. So again, I can't stress this enough. Have I imparted on you enough the fact that you need to know what functions look like? It will help you in who knows when. Okay, but definitely with limit questions. Oh, that's gross. I don't know why they do all that. Oh, here's a really cool one. Yeah. Now, real quick, I really want to make sure this makes some sense. What is this piece going to? Infinity. What is this piece going to? No, just this piece. Also infinity, right? Is infinity minus infinity necessarily 0?
No.
Nope.
It's an indeterminate.
It is not necessarily 0. It's an indeterminate form. Yay, we want more of those. I cannot determine the answer the way it is currently. Why the hell is that? Because infinity is not a single thing, it's a process. If this is growing faster than this, the answer could be infinity. If this one's growing faster than that, the answer could be negative. If they're both growing at about the same rate, it could be any finite number. I don't know if you guys are really with me. So infinity does not equal infinity. It is a process. So in this case, it's all about the rates. It's how quickly they're going to infinity. Yeah.
So if the under the radical was x to the 4th power instead of
Yes, I like the way you're thinking. So you could argue that I know the square root of x squared is basically x. So they should both be growing at the same rate. But how do you prove what the limit is? Hit me with something that happened earlier. Try and make, give me what did you say earlier? What would I do here? Now this might be freaky because there's no bottom.
Oh, the conjugate.
I like. So if I write this as, I can multiply top and bottom by what?
X squared plus 1 plus x.
So then I get, notice how I keep writing my limit?
Yeah.
If you want to, you have to have something here. So in the past, I have let students at the top of the problem, they could say L equals limit x goes, so you just write an L up front. It does get a little annoying to write this, but if you don't write it, you're suddenly wrong. Yes?
We use like an arrow to carry it down.
Yes, some kind of indication that you understand that it still needs to be done. It'll save you from yourself too, because you could get to the end and forget you got to do the limit. So what do I get on the top?
x squared plus minus x squared.
I'm sorry, what did I do on the bottom? I'm so smart. Yeah, so it's gotta be the same thing on both. Good job, Jeff. So on the bottom I get this, so I get the limit as x goes to infinity of 1 over this. Too big. My square root was too big. What is the bottom going to, very obviously?
Why did it all of a sudden end up from x squared plus 1 minus x squared to being 1?
Well, what's x squared minus x squared?
Minusing x squared from x squared.
Yeah, these cancel.
Got it.
What's the bottom form now? This is going to infinity, right? And this is going to infinity, but the bottom is now infinity plus infinity. Is that indeterminate? No, it's freaking infinity. So what's the whole thing going to then? No, if the bottom is going to infinity, whole thing's going to 0. I'm dividing by big, big, big. I'm getting small, small, small. Or whittle jack. Okay. All right.
So, putting undefined would be wrong, right?
Especially for this, because it's not, it's 0. 0 is a very well-defined number. It is the number that always finds a way to screw us over. That is the official definition of 0. Oh, that's not very interesting. What's a good one? I don't care about that. Here, can you guys tell me this?
No.
Oh.
She's both for everything. Not possible. I mean, wait.
What saves your ass? Knowing the shape. Do you know what e to the x looks like? Where's the asymptote? Yeah. Where's the asymptote for e to the x?
0.
And that's what, as x gets really
Small.
big negative. Small, we think of 0.
Yeah.
So big negative. And that's exactly what it's asking. So that's why this answer is 0, because that's exactly what it does. If I raise a number to a negative power, it becomes 1 over the thing, yes? So if I raise it to a really big ass negative number, it's now 1 over thing to a big ass, it's getting stupid small. Does that ever get to 0? No, because the top's always 1. Can't get to 0. But it gets as close as anybody would want it to. Okay, how are we feeling out there? This whole section is devoted to analyzing how infinities mess with limits. And we've seen some infinities before, so some of this is old news. All right, Jeff, you didn't bring it, did you? No. All right, I can't swallow my shame and put my glasses on, too bad.
A quick question.
Yes,
All these rules only apply if limits going towards infinity?
sorry?
All these rules apply only if the limits going towards infinity?
Well, we did a couple examples where it was going to 5, but it was, the answer was some kind of infinity. Yeah. Some of these are all about, do you understand the shape of the function? Some of these are all about, do you remember conjugates? Some of these are all about, do you remember precalculus, right? The horizontal asymptote. Okay, yes? I would just say evaluate the following limits, and then this would be a problem, and all the other ones we did would be problems, yeah. Okay. Okay. Anything else interesting? Yeah, slightly interesting. No. No. Okay. Beautiful. Now. What time is it? Let's do this. Do you guys want to, let's take a break. You've had a quiz, you've listened to me talk about infinity. Everybody needs a freaking break. So let's come back at 5 till.
So section.
Yeah.
So if, say we couldn't solve for it for 0 and everything, and we just got infinity minus infinity, would we put undefined or does not exist?
What time do you get out?
It's indeterminate.
So,
So I don't even know. Huh?
so would we put undeterminate?
Okay.
We won't see any indeterminate form that we cannot do
I
something
get
algebraic
out,
to determine.
Tuesday is my short day.
Do some
Tuesday
exist.
I get
Yes.
out at
Can we
Right.
develop ways eventually so that we can do any limit?
And
Yes.
then on
So,
Thursdays,
yeah,
I
so
get up
eventually
at
we'll be able to do, you know, like, we're never gonna see a limit in the early going
Yeah.
where I can't do something algebraic to make it something I could do.
I was just thinking because Tuesdays I have to take
Yes.
the trolley home because my mom is at work. That's the day that my dad goes into the office. My brother is now in school, so we won't be able to do that. And my grandma.
Get some points back. It depends on how many points you end up missing. So if you get below an 80, you get a point for every 4 points you miss.
So she knows
If you end up getting 40, for example,
to the
you get 60 points, divided by 4 is 15, you can get 16 points back.
picking up from there, but she would take it up. So I was taking the trolley home, and then Thursday.
So guys, real quick,
2:05.
just to be a little more specific about the corrections,
So I take
because I can't remember, I talked about this on the first day.
the trolley.
If you get an 80 or above on your quiz, you get it back. Never change the original work, you'll make corrections. If you get an 80 or above, you get up to 5 points back. Up to 100, right? So if you get all the corrections right and do them all, you get 5 points up to 100, right? So if you get an 81, you do all the corrections, get all right, 86. Get a 97, do all the corrections, get all right, 100, right? Everybody with me? If you don't get them all right, you might get fewer points back. You'll never get less than 0. You know, I'm never gonna take you down. Even if I'm like, that was wrong and I missed it. You know, I would need everybody to understand. Even if you made the mistake and I missed it, that was my fault. I'm not gonna take, oh, let me make the 80 become a 60. No, I'm never gonna do it. Never hesitate to give me it, even if I miss something. I'm not gonna count it against you yet.
If we miss everything and then do the corrections.
That'll still
is it
work.
Full credit?
Yeah, no. Well,
Oh, Lord.
what did I just say? What's the only way to get 100 from corrections is if you got a 95 or above, correct? If you got a 94, what's the highest grade you get? Okay. Now, if you get below an 80, and you make all the corrections, get them all right, I will give you 1 point for every 4 points you missed. So if you got 68, how many points did you miss?
12.
Nobody's like, you would have made a mistake. I would have missed 12. 32 divided by 4 is? 8. So you can get 8 points back. You can go from 68 to 76. If you do all the corrections, get them all right. Y'all with me? Yeah. Alright. It's sort of like taxes. If you want to pay less taxes, make less money. If you want to get more points back, make a lower score. That doesn't make any damn sense, does it? So my philosophy is, if you got a lower score, you got more work to do, I'm gonna give you more for your points. You're never gonna get up to where somebody else was. You guys kind of with me? So feel how you will about it, that's how it is. Also, if you read the syllabus, if you make corrections to a quiz and then you do better on the corresponding test, I will make your quiz grade go up, proportional to the number of corrections you got right. So for example, let's say you get a 20 on a quiz. How many points did you miss? 80. Divided by 4 is? 20. You can get all the way up to a 40. Celebration time. But that day, you didn't have breakfast, you woke up late, you had a major headache, your car broke down, you had to walk, little raccoon peed on your shoe. So you come in like, you're doing something. Alright, test. Totally ready for the test. You kick ass on the test and you get like a 83 on the test, yes? Your 40 becomes an 83 because you've got all the corrections right. If you get half the corrections right, I'll average you halfway. So what are you with me? The reason I do that is because if you miss a quiz and you communicate with me, I'll count the next test in place of the missing quiz also. So to make it fair for people who actually take the quiz, I'll let it become the test score, yes? So anyway, well, if none of that makes sense, make corrections, things better.
So if we can completely fail the quiz and then we get to the test, we get 100%, we get 100% on our quiz.
If you made all the corrections of the quiz and got them all right, yes. Okay. I like thinking he's got a little swirly math around his head. I can see it. This is awesome. Okay. What really surprised me is how many people don't make corrections. Even if you got a 99, get that damn point back, because at the end it could be that little determiner between who knows what. Yeah. Okay. Okay. All right. So
I am gonna get into section 2.7 unless you guys had any lingering questions from 2.6.
So with this new indeterminate form, it's just the same thing. Like,
Oh yeah, so
if
now.
you were to do the zero, if you were to get the 0 over 0, it's the same thing. If you were to get infinity minus infinity, you go through the same process.
Not the same process, but you understand that there must be some algebra you can do. I'm sorry. Oh yeah, I'm sorry. Thanks, man. I'm not used to using the projector yet. I wasn't sure what you were doing. You're like, it's fabulous, Jeff. Another one that kind of came up earlier, I didn't really point it out because it wasn't that big of a deal, is this one. We saw this one. A quick little example of this one is the limit as x goes to infinity of 4x squared minus 7 over 2x squared plus 8. Isn't this going, what's the top going to?
Infinity.
What's the bottom going to? So it's technically an indeterminate form, but why is this not hard? Because we evaluated it in pre-calc already. We made shortcuts in pre-calc that were built on doing this algebra. So that's why this is not as hard, because we got a shortcut already related to this. What's this answer?
2.
2. I like it. When in doubt, the answer is 2. No, that's not right. Don't do that. Okay. One thing about 2.6. Let's say the limit as x goes to infinity of a function is 3, right? What does that mean exists at 3? Yes. So it would have to have 1, 2, 3. It would have to have this. Yes? Can somebody try to tell me, if I'm going to draw a function where that's true, what has to happen eventually? Like, do I need to be anywhere near 3 at this point? No. In fact, I don't need to be anywhere near 3 for a long ass time. Roughly. You have until
Just before.
So at some point, you can do all kinds of weird ass shit, but at some point, let's call it m, at some point, forever past m, I will be some distance away at most. In order for the limit to really be 3, at some point, I must get arbitrarily close to 3. I cannot forever go, I'm close, no I'm not, no I'm close, no I'm not. If the limit really is 3, I eventually have to calm the shit down. You guys kind of with me? Alright. So given some distance away from 3 for my output, I have to be able to find somewhere on my x-axis where I'm always closer than that. If I cannot find that, the limit cannot be 3. Does that make sense? That's kind of related to that section 2.4 that I had to skip.
Can the graph still go up and down?
Of course,
3?
but it has to live within those boundaries, right?
Zone or whatever?
So if I claim that I have a function whose limit at infinity is 3, and somebody comes along and says, oh really, then I want you to be within 0.1 of 3. 3.1, I have to be able to find somewhere where my function is forever in that. No matter what they tell me, if I cannot ever do that, how the shit can the limit be 3? Because what's the whole idea of the limit being 3? Eventually it has to get close. And this whole idea of the epsilon thing is defining close. I love you guys, and you're all like, we skipped that, I know. So just to show you, the book has much better pictures of what's going on here, right? Look at that, that's just too pretty, are you kidding me? So at some point, I have to live within that, and if I cannot find that point, the limit's not that. Okay. Yeah. So, yes.
I had a question just because from the other problem we were doing, the square root x x squared plus 1 minus x. I was wondering why it was after we had infinity over infinity it equals 0.
Oh, definitely not. So let's see, what did I write? Oh, here it is. Infinity over infinity. So the answer to the limit is 0.
Yeah, because then the 1 goes to positive infinity, the bottom goes to
No, careful. Is there an x up here? X is going to infinity. This is 1. If I change x, what's the top? 1. So the top is always 1. Yeah. I like it. Okay. Cute. Go. Okay. So 2-6 is all about, here, let's do this. Let's look at 2-6 homework a little bit. See what kind of weird questions they're gonna ask us. Give us some heartbeat looking stuff. They're gonna ask you questions, but this time it's gonna be about infinity. So that looks very similar to questions we've been asked before, right? They give us the graph and they ask us limit questions. So what do you think about, they didn't really draw this very well, but what do you think about the limit as x goes to infinity? They're being very heavy-handed. It looks like -2, yes? And what's the limit as x goes to negative infinity? Positive, okay, so that kind of problem we're very used to. Now I'm just thinking about it in terms of getting really big or really big net positive, big negative, okay.
Based on how close you are to the limit.
Yeah, they're gonna make it very obvious what their asymptote's supposed to be. Thankfully. What about here? Here they tell me sketch the graph. Okay, we've seen problems like that before. So what would this mean should be present on your graph?
Rose dot at 0.
No, careful.
Horizontal asymptote.
Let me zoom in a bit.
Horizontal asymptote.
Yes, there should be a horizontal asymptote
At 0.
along 0. And by the way, what is y equals 0? What's another name for y equals 0?
The x-axis.
There he is, the x-axis. So there should be a horizontal asymptote along the x-axis. And also,
at 2.
at 2, along y equals 2. So when I go to negative infinity, I approach 0. When I go to positive infinity, I approach 2. You guys with me? Okay, let's try this. So this first thing, this guy. Looking at this. Forget about these guys, I don't care about this. This guy. As x gets really big negative, my function must approach 0. That's how to read this, yes? As my x's get really large negative, my outputs need to get close to 0. That's what that says. And horizontal asymptotes are all about what my function does as my inputs go to some kind of infinity. So as my inputs get really big negative, my outputs must be approaching 0. So I just chose to come from below for whatever reason, yes? And then it also says, as my inputs get really big positive, my outputs must approach 2. Which means at some point, so in the middle here I could be doing all kinds of weird shit, but at some point I have to be approaching 2. Now this is not an answer for this problem because I totally ignored what these guys said because I don't care at the moment. You guys kind of with me? Okay. So if I see a limit as x goes to some kind of infinity is a number, that is a horizontal asymptote. Because what are horizontal asymptotes all about? What do my functions do when my inputs get really big, positive or negative? That's what horizontal asymptotes are. Okay. I don't want to play poker with any of you. Okay. So that's all these. Basically the same idea, sketch a graph. Then you have this big collection of evaluate. Find the limit. So do you see how many of these look like the little, what do you call it? The little pre-calculus idea, right? Oh, now you don't see shit. There we go. All of these first ones, aren't they all just, where's the degree bigger or are they the same degree? You guys with me?
Yeah.
So now that we know pre-calc, you can do these problems. What do you think I do with this problem?
That was the one that you had up there. Oh, but it's a minus on the top and a plus on the bottom.
Yeah. So it's the limit as x goes to positive infinity. Now listen, before you think conjugate, what would you do with this one?
Factor.
Subtract the exponents from each other.
Degrees.
So is it a rational, is it a division of two functions?
Yeah.
Polynomial or radical, yes. Are the degrees the same?
Yes.
So what's the answer?
1/3.
Negative 1/3. That is pre-calculus. We're just taking it and going, I'm not gonna reprove that, I can just, now it's the limit, it's the same idea. What's the degrees here? What's the degree of the top?
1/2.
Beautiful! What's the degree of the bottom?
1/2.
Okay. So the answer is gonna be
1.
the ratio,
-1.
-1, done. If the degrees on the top and bottom are the same. And why is the degree of this 1/2? Because how do we rewrite square root of x? X to the 1/2. Because the square root is cutting a number in half multiplicatively. Okay. So all of this first part, in fact, let me see if there's any problem that isn't. No, every single one of these problems up to 28 is where's the degree different, or are they the same? Every single one of them. What about 30? Did we do a problem like that? We did what? Conjugate. 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 Is this conjugate? No. This is something
It
else.
doesn't have a square root.
Yes, it doesn't have a square root. Alright, so I can't remember if I signed this. If I did, have fun with that. Okay. Yes,
For number 30, do we need to use the conjugate or can we just let?
30. Alright, if you can fully explain to me what you see, I might let it go. This, yeah, they could make a more interesting question, but okay. Same kind of, now up here they're doing stuff related to, do you remember how these things look? But just a little more interesting. I like it a lot. Okay. Did we talk about what arc tangent looks like? Inverse tangent? Yes. So that problem's nowhere near as bad as it looks. Something, no, it's it looks like a cubic that fell over.
Oh, yeah.
Okay, enough of that. And then you get all the weird shit. Look at this. Do you remember end behavior? Oh boy, that's traumatic for some people. So, what I want to do now is I'm going to give you this handout. I got two handouts, by the way. One of them is a practice test. So if you need to leave before I've given that out, make sure you grab that.
I'm not gonna get into derivatives. Apparently gonna get into derivatives before the test.
Right. Well, you don't like derivatives?
No, I love derivatives. It's
Yeah.
limits that I
I don't
hate.
like them. Yeah, limits are hard.
Gotta remember.
The limits are stricter.
Oh my gosh. How many rules are there to limits? Like 8 or something?
Yeah. Over animal.
Oh, it's 52 points.
I need to check my old, I need to check my old lab. I got it in my bag somewhere.
Yeah, that's in my desk.
Yeah.
I kept all of my calculus stuff from last night. I was like, I am not screwing this
No, I think I got rid of it.
So guys, kinda did this out of order, but I'll be okay.
When are we getting into derivatives then?
What is this symbol right there?
That means that it's a prime.
Yeah, how many people don't know what that means at the moment? Okay, so, good. So this is a little teaser. Let's talk about what that means.
Okay. And this is 2.7 then?
This is 2.7.
Man,
What's up?
I'm
2.7.
used to spending like a whole entire week on a section.
Okay. So let me go back in time a bit. If I want to find the slope at a point, guys, if I want to find a slope at a point, what does algebra say?
That you have to have 2 points.
Algebra says you're insane. So what do we
Gotta have
do?
2 points.
What do we, oh crap, Jeff, way to give it away. What do we do? At a very small amount.
Try to do it with 1.
Well, we can't do it one. It's impossible to do it one. But what we did instead is we took a whole lot of time to develop a process that will help us, and that's the limiting process. So we're going to finally do what I talked about in the first day, which is
Tangent.
tangent. All a tangent line is, if I am swinging something around my head, and I have nothing here, damn it. Oh, yes, I do. No, I don't. That would be scary. All right, I'm like, ooh, I do. Come here. This almost works. Screw it, they got it freaking. So if I'm swinging something around my head, and I let go, is it not going to fly off in the exact same direction it was last facing when I was in my hand? So what I mean is, if I'm swinging something around, Jeff, turn it on. If I let it go right here, it's going to fly off in the direction it was last facing. Because the only reason it's going in a circle is because I was holding on to the damn thing. The minute I let go of it, it's going to fly off in a straight line. This is the tangent line. It is the line that has the same slope as the function does right at that point. So just to remind you guys, what do you think the slope is right here?
0.
0. What's true about the slope after that point?
It's decreasing.
It's negative. Isn't this slope negative?
Yes.
If I'm on this roller coaster, I'm going down now. This is where you start to go, what was I thinking? Oh shit, I shouldn't have done this. Okay. So now I'm just curious, what is the slope right at that point? What exactly is the slope? And right now, algebra would look at these two and how would I get the slope between these 2 points?
Compare the coordinates. The x, the y.
So what's the
one,
slope? Y2 minus?
y1 and x2.
All right, now be a little more formal. How do we get my y's? So y2 would be f of?
X plus H.
F of, yeah.
Good. F of x plus h. Minus f of x. Good. All over.
Oh.
Yeah, why is it h? Because it's x plus h, x2 minus x1, and the x is? Cancel. You all right, Sarah? All right. I won't take it personally. You know, it's just a fundamental part of my entire career. That's okay. You can hate it as much as you want. All right. So, algebra is cool with this. We're not cool with this shit. Because we want to know the slope of this. Of course, what can we now do? We have a new tool in our toolbox.
Plug stuff in.
I can let h go to
0.
which would make this actually 1 point. Do we ever get h to 0 if I use a limit?
No.
So algebra is eternally happy because it always has 2 points, and we're happy because we can see where the hell that thing's going. We can see what's going to be the slope at that point. So here is the limit definition of slope, and I'm going to give it its calculus name here in a minute. Dadgummit, this is a straight pen mark. And I made my H weird. Oh well.
Didn't we deal with this equation like before?
This
like
is just nothing,
right
right?
at the beginning of
We did. this was my motivation for us to learn limits. And now that we've learned a hell of a lot of shit about limits, we're now able to do this for all kinds of different functions. You guys with me? This is the slope, but in calculus it's called the derivative. And it's given a symbol, f prime. So this symbol means the slope of the function at a point. That prime symbol is derivative, it's slope. Okay. So if I ask you what is the derivative, I'm asking you what is the slope at that point. So let's actually try a concrete example, dear God, Jeff, please. So what if I give you kind of a nice function here? What about x squared minus, no, Jeff. Just do x squared. Okay. And let's say I want to know the slope at 2. I want to know what's the slope at 2. You with me? We already know one thing about it. It's definitely going to come out positive. But I just don't know how big. Why would it be silly for me to ask you the slope at 0? Because at 0 it is obviously 0. Okay. So here's how this works. I want to know the slope at 2. So that means that's going to be my x point. Yes? And I'm going to pick something 2 plus h. I'm going to go a little bit away from 2. And then I'm going to approach 2. Are you guys all with me? By letting h go to 0. So here's what this looks like then. I want the limit as h goes to 0, f of 2 plus h minus f of 2 all over h. Let me let that soak in. So up here, x was undefined. Because I didn't know, it's just some general point. Now I know I want to know at 2. So now I can put a 2 in. If I do this math, I will get the slope at 2. Right now, that doesn't mean a hell of a lot to you, right? You're all like, okay, we've achieved something. But this is huge. This is mathematics finally able to tell how quickly something is changing at a given time. If I know the general function of something, I can tell how much is going to change at some point in the future. You guys kind of with me? Missiles coming at us. I know how quickly it's turning. Is it going to hit this building? Calculus, help me. Okay. So let me write this again on the next page because I've run out of room. For some reason I have cardstock. That's neat. So the function was x squared. I'm curious at x equals 2. And my limit is f of 2 plus h minus f of 2 over h. So can somebody help me? What is f of 2 plus h? Let me build what we need. I need to know what f of 2 plus h is. How do you get f of 2 plus h?
Plug it into the function.
Yeah. How exactly?
2 plus h squared.
Yeah. That's it. So what is 2 plus h squared? Is it 4 plus h squared?
No.
Hell no, because what are you missing?
4h.
4 plus 4h plus, yeah, FOIL that out, right? Is everybody with me? So what am I doing right now? I'm building what this thing needs. This thing needs this, let me build it. What else does this thing need? Feed the beast. F of 2, what's f of 2? Holy shit. So now I've built what that thing needs from me. Let me plug it in. So this is the limit. H goes to 0. F of 2 plus h minus f of 2 all over h. What happens? Yeah, the 4's die, and then each one loses an h, yes? So you got 4 plus h. Is that okay? This h cancels one h out of both of those. Is that all right? And in the parlance, there's a word. In the parlance of what I was saying earlier, I just killed the problem. Why could I not plug 0 in for h up here? Because it would be 0 over 0. We just killed the problem. Can I plug a 0 in now? And what do I get? 4. Yes, Brendan?
Right there, it kind of looks like you just,
4 minus 4 is 0.
right.
When I divide by h, I lose an h from each term. So then I'm ended up with 4 plus h.
Cool.
Okay. Kind of look like you just.
I know, it looks like I just went, I don't like this.
Yeah. It's
What does this mean?
That the slope,
Your asymptote is at 4.
No asymptote, no.
that the slope
At
is 4.
2, the slope of the tangent line would be 4. So if something was going in this orbit around a sun or something, and the sun suddenly disappeared, it would fly off in this direction. Because the thing making it curve would go away. So now it would just go straight along the same direction it was last moving. Just to give this a more cosmic scale, instead of me flipping something around my head. What would be true, what do you think would be true with -2? Since this is symmetric. -4, right? Because the graph is nice, I can kind of figure out other things. Can we stop for a minute? So here's what this looks like in, I always say stop for a minute, I stop for like a second. F prime evaluated at 2 is 4. This means the slope of the function at 2 is 4. Or the derivative of the function at 2 is 4.
Will it always be h approaching 0 to figure out the slope?
Let's see how to answer that. Because there's a whole other way to do this, which we don't really use that much. The way we're going to do this, yes. This is what's called the limit definition of derivative. This is the limit definition of derivative. So if on a test I say, use the limit definition of derivative to find the slope of blah, 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 that means do this. I like it.
One more time, what's it called?
It's the limit definition of derivative. So let me make it more formal. So f prime of x is defined to be the limit is h goes to 0, f of x plus h minus f of x divided by h. That is the limit definition of derivative. You're welcome. Here's the other one, just to show you this real quick. You guys got that? Is that all right? Do you see how this is still y2? Let me zoom in on this. Do you see how this is still y2 minus y1? Come to me. Come to me. There you go. y2 minus y1 over x2 minus x1.
Yeah.
And do you see how I'm letting x go to a so that these get close to 0? Get close to each other? You guys with me? That is a whole other formulation that we just don't use as much because depending on the function, I have to factor the top to make something cancel, and that factoring can get really difficult. You guys got it with me? I'd much rather have what we just did, which is where I FOIL stuff out and then I just kill h. That is much more easier to do in general. I'm really sorry. You guys look really defeated. I'm sorry. You guys doing okay?
You put the other one up real quick?
Yeah, this guy.
Yeah.
Let me zoom back out.
Okay.
All right, so let's try one more problem, then we're gonna, well, let's see. Oh, this is only 5:30, cool. Too bad. So I wanna do something, all right, here we go. Let's do this again. Let me give us a different function. So I wanna know the slope of the function at x equal to 9. Can you set up the limit definition?
So would it be f prime of 9?
Yeah, hold on, one second. But you're right, it's a good start, but hold on. Just take a minute and try to set it up. kinda do it in stages here, so like Mike said, f prime of 9. So this would be the limit as h goes to 0. I can kinda do it like this first. What's gonna go in here? No,
Square root
No, no, no,
x
no.
minus h.
9 plus h.
9 plus h, thank you, minus f of 9, all over
Oh,
h.
okay.
Okay. You didn't have to do this, I agree with you. Then you can throw in what the function is, right? What the function?
Square root 9
Yeah,
plus
the
h.
square root of 9 plus h. Minus
Three.
square root of 9, which is 3, I love it, all over.
H.
Now, real quick, does that look at all familiar? I mean, not that specific problem, but we did a few problems just like this, yes? It's almost like there was a reason.
Conjugate?
Yeah, totally, this is a conjugate thing, right? Because what form is it in right now? If I try to plug a 0 in and get rad 3 minus 3, rad 9 minus 3 is 0, and I get 0, 0, 0, oh shit. Yes,
It's like that difference. They call it a-
difference quotient,
Yeah,
yes. That's what this is, that's the difference quotient.
yeah.
Why did f of 9 become 3?
Because what is f of 9? You're good. So what's the conjugate?
Square root of 9 plus h plus 3.
Alright, so let's see if that does anything for us. Really hope so. What's square root of 9 plus h times square root of 9 plus h? 9 plus h. Minus 3 this, plus 3 that, the middle terms cancel by
Minus
choice,
9.
we've made it.
Mhm.
Minus 9. All over h. Times Jeff. Square root of 9 plus h plus 3.
Wait, why do we get the minus 9 up there?
Oh, negative 3 times 3. Right?
Got it.
This times this, and then the middle terms cancel, and then this
Got
times this. Yeah.
Okay.
And why do I know I'm on the right track? What's gonna happen on the top? Which means then I can do what? Kill the h. So now I have the limit as h goes to 0 of 1 over square root of 9 plus h plus 3.
And then h goes to 0.
So if I let
So
h go to
3
0,
plus 3, 1 6.
yes, I get root 9 is 3 plus 3,
1
1
6.
6.
Okay.
What does that physically mean?
That
Slope is 1
Um,
6.
at
Yeah, the slope
f
of rad x.
prime of 9
Okay, f prime of 9 is 1
is
6.
1 6.
Which physically means the slope of square root of x at 9 is 1 6. Now, let me capture what we just said. Has everybody got that? You guys doing it right?
I'll
Yes.
get it on the video.
Go ahead, Mike. What's up?
Slow down a little bit.
Oh, alright. Can't go slower than not saying anything. Yes.
So instead of limit h goes to 3, can I just put f prime?
No. So
Like,
this, what we're doing right now, equals f prime. So you can't replace the limit with it. F prime equals the limit as h goes to 0 of this.
So we can't just say 1 6 is the answer. We have to put f prime of 9
No, that's okay.
equals
Yeah,
1
f
6.
prime of 9 is 1 6. So if you circle this, you'd be fine.
Okay.
Okay, so let me stay there for a moment.
So the f prime of 9 is just like with the limit where it has to stay with it.
Oh, no. It's f prime of 9 equals all this stuff, equals 1 6. If
Okay.
you circle this, you're fine. I just put that there because somebody said something about replacing this and can't do that.
So 1 6 is a slope.
Yep, 1 6 is the slope of this function at 9. If you think about the square root function, what is it doing very quickly? It's becoming very slow to grow. So at 9, it has gone so far over that it's barely growing. It's going up by 1 6 every step at 9. Alright, let me see. Some of you guys still look a little too conscious, so I'm going to do a little more with this. Let me summarize what we know here. Can somebody tell me what point we just went through? What point we found the slope at?
9 1 6.
No, 9 3. Yes, 9, 3.
Oh,
9, 3. You with me? So at 9, 3, we have a slope of 1/6, yes?
mhm.
Stay with me, this is cool. I'm gonna show you. You're all like, you say that about everything. Can somebody help me find the equation of the line that goes through 9, 3 and has a slope of 1/6? This is gonna be the tangent line. We're gonna find the equation of the tangent line. I'm gonna graph the hell out of it, and then we're gonna leave. I'm gonna go. So, light at the end of the tunnel. Come back to me. Come back to me. How do I find the equation of the line here? Do it. I'm sorry. So yeah, y equals mx plus b. So 3 equals.
Times 9 plus
You got it. I love it. So then 9/6 is 3/2. 3 minus 3/2 is b. What's 3 minus 3/2?
3/2.
3 freaking halves. I love it. A whole 3 minus half of 3 is half of 3. So what's the equation of the line?
Y equals 1/6.
1/6
1/6x
plus 3/2. And that is for the function square root of x at 9, 3. Okay. Let me
So-
let you guys.
Then, since, would that be the derivative?
Yes, the derivative is 1/6. We just use the derivative to do some more stuff, right?
Oh, okay.
Yeah. Man, this is a crazy mess of it. This is the last thing for today. Yes.
So I seen like the notation with dy over dx and all that. Is that the same thing?
Do it again, sorry.
Like-
Oh, yeah. We'll get to the different notations. I just want this to sit with everybody for a bit.
Just like how I could see that, that 4 was already going to be, the derivative, because if you bring the 2 down with the power rule and then you do.
Oh,
2
yeah,
times-
you can't do anything you know before we officially know it in this class.
On the section 2.7 on the paper you gave us,
Yes.
do we need a function for that? Solve any?
No. So we'll get to that. Hold on. Let me show you this. There's a square root, yes?
Mhm.
We just figured out 9, 3. 9, 3, right there. That's 9, 3, there. If I graph the line we just got, it better frickin' come in, touch my little dude right there. That didn't sound like it, too bad. And then fly off, right? I just can't go a day without saying something. You guys ready? So see how I put do you guys see that? I don't know, it's really tiny, but that's our 1/6x plus 3/2. That's the tangent line we just got. So if we turn that on, it touches right. So if I zoom in at 9, is this 9, 3? I've lost touch, yes. If I zoom in, you can't even see it, it's touching. Oh. So if I zoom out, then you can start to see it. See, here's the tangent line. So if something was going on a trajectory of a square root and it got to 9, and then and then for some reason, whatever was making it curve left, it would go off along the blue line. It would shoot along the blue line. Are you guys kind of with me? It seems like a semi-decent, important thing to know about various things that could be coming at us. Missiles, comets, meteorites, rockets, whatever, right?
How to shoot up with lasers.
Space lasers up in space. According to some people, setting fires, it's crazy. Okay. Looking back at this. I lied to you, that's okay, you guys are right. I'll tell you what, so this guy, first thing on Wednesday, Wednesday, because Monday's a holiday. We'll do this, and then the rest of class will be devoted to review for the test. The test is only going to go up through section 2.7. You do not have to do 2.8 homework yet. 2.8 homework will be due the day of the next test, test 2. Does everybody understand? So here's a practice test, and I will have an answer key for this.
What's the practice test?
Sorry?
I thought this was the practice test.
Nope, that was just a hint.
You said it was a practice
I
test.
said I had a practice.
Let's stick my notes together.
You guys, Wednesday is gonna be a review day. The answers for this, we're not gonna do any new material on.
You got one. Yes, I'm gonna go.
Oh yeah, number 7 will be extra credit. Yeah.